Alright, so for today, in this video, we are going to discuss our chapter 6, which is we are talking about the numerical solution of equations. This is a short chapter and it is quite simple to understand and to answer the question in the exam. Okay, so let's have a look for the learning outcome first. Okay, so for learning outcome 6.1, that means after this video, you need to locate approximately the root of an equation by the means of graphical consideration. And the second learning outcome will be locate the root by using the method of sign change. So here in general, you will see that the learning outcome is to ask students to locate the root. That means to find out the root, okay, by using two different methods. The first one is graphical method. Another one is the sign change method. So no matter which method are you using, the main idea, okay, or the main aim for us to apply this method is to locate the root. Okay, so what's the meaning of a root? Okay, so let's have a very rough discussion on this. All right. Okay, so in all the previous lessons, right? Okay, so for most of the chapters, we actually learn how to solve the equations in maths. And then we have some techniques when we want to solve the equations. So as an example, okay, like when you're having x squared minus 4x minus 5 equals to 0. So last time when you never learned MS before, you might not able to solve this question or solve this equation, right? Okay. Once you know that it belongs to a quadratic equation for this part, for this equation, then you know that okay, to solve a quadratic equation, you can use the method that you learn, right? So such as maybe you can use factorization, okay, which is something like you can factorize it out nicely, which is x minus 5, and then x plus 1 equals to 0, and end up you will get the equation, the root. So x equals to 5 and also the x equals to 1. So the values of x here, we call them as root. So x are the root here for this equation. Okay, so like for this particular equation, you know that it belongs to quadratic equation and you use the quadratic method to solve it, factorization. Okay, how about if let's say you're having a cubic equation. So if you're having a cubic equation like x power 3 minus 8 equals to 0, so this one might be quite straightforward. For this part, you can actually try to move the 8 over and then you just take the cube root, right? So if you take the cube root, you straight away get x equals to 2. Right, so you know how to solve all these equations by applying some knowledge that you learned before, okay, or maybe some technique that you learned before to solve all these equations, which is not so hard, right? But in this world, there are a lot of equations that we are not able to solve it, or we are not able to get the root, okay, by using the methods that we learned so far. All right, so as an example, you can see that this equation x power 3 minus e power x and equals to 0, you will realize that no matter how you try to solve, no matter what method, even if you take log, all right, or factorize or whatsoever, you actually cannot get the root. You will start halfway and cannot get an answer, cannot get a value for the x. Okay, so for all these kind of equations, there are a lot in this world, right? Because the equation that we learn to solve is very limited type only. There are only limited types of the equation that you can solve. All right, so now for all this type of equation that we cannot solve, what are the methods that we can do, or how can we continue to get the roots? So here we are going to focus on the approximate solution. So approximate solution means that you can still, by applying a certain method, you can still get the value of x, but this particular value of x is not the very accurate answer. It is accurate up to a certain accuracy only, like maybe up to 3 decimal places or 4 decimal places and so on. So we call them as approximate solution. All right, okay. So here we come back to our learning outcome. So just now our learning outcome is to locate the roots. So to locate the approximate roots or approximate solution by using two methods, right? So there are two methods here. The first method is graphical, as mentioned in the learning outcome. And for the second method here, we are having the sign change method. All right, so for this video, we'll focus on graphical method first, and we will discuss sign change method in the next video. Right? Okay, so let us start with our example here. Okay, so now how the question will ask in the exam when they want you to use the method, when they want you to locate the approximate roots. Right, so you can have a look for example number 1. Okay, so for example number 1, you will see the keyword that they ask you to sketch a suitable pair of graph. So you see the word pair, right? That means you have to sketch 2 graphs. Okay, and they want you to show that the equation cotangent x equals to 1 plus x squared, where x is in radians, okay, has only one root in this interval. So there are a lot of important phrase here, important words here. The first one is, you can see that they ask you to sketch 2 graphs, a pair of graphs. That's the first thing. And the second thing is, what kind of graph should you sketch? So you should sketch a graph about this equation. All right, and from now onwards, you have to always know, or maybe I mentioned it before, then you should always remember this. Besides the trigger, right, when you want to solve or when you want to deal with the x, the how to say, the angle of the x in trigo, like cos x, sin x, cotangent x, and so on, everything is in radians, unless your equation is unless that particular chapter is in trigo, then only will use angle. Like differentiation in trigo, integration in trigo, right? When you substitute all the values of x, you should understand that all the x there are in radians. Okay, right. And after that, this is another important information. They want you to sketch a graph from 0 until pi over 2 only because they're interested about this range only, this part. So you can draw the graph from 0 until pi over 2, which is 90 degrees. And then finally, you need to show from the graph you have only one root, okay, for this equation. All right, so how should we do and complete this? Let us start now. Okay, first of all, based on the equation that they give you, they want you to sketch a pair of graphs. Therefore, usually I will tell students, you draw one side, one graph is cotangent x. So you need to sketch y equals to cotangent x. All right, and another one is y equals to the equation on the right hand side, the expression on the right hand side, which is y equals to 1 plus x squared. So to sketch all the graph here, you need to do some revision on trigo part, how to sketch a graph for cotangent x. And then you also need to have some idea on transformation of graph, how to sketch a 1 plus x squared. So all these are some small knowledge that you learned before, but we seldom use it. So you might need to take some time to go and do some revision on this. All right. Okay, so let's start. For y equals to cotangent x, again, if you forget how to draw, you can refer to the graph or you can search it online. Right, I think we covered it before in our chapter 3 in trigo. Okay, for A2 syllabus. So you can have a look in the chapter 3 notes. All right, so from 0 until pi over 2, when you want to sketch a graph, it will look something like this. Okay, so I'm interested only from 0 until pi over 2. So this is pi over 2. According to the, okay, so maybe I just draw a line here to remind you that I only want to cover from 0 until pi over 2. So the graph for cotangent x is the inverse of tangent x. Is the reciprocal of tangent x, right? Okay, so according to the graph that I have, it should be something like this. So this is y equals to cotangent x. There's no special technique. What you need to do is that just refer back to the chapter 3 notes, or you can learn again how to draw the reciprocal function. Okay, like how you sketch the cotangent X from tangent. So I think I covered it before in chapter 3 video. So if you're interested, you can go and have a look. All right. Okay. So I will just save our time here. So our cotangent X, this is the graph. And then I want to sketch 1 plus X squared. So previously, okay, in AS level, you know that X squared is a U-shaped graph, a parabola like this. And then when you're having a plus 1, okay, so what happened to the plus 1 here? You have to shift or move the whole graph up 1 unit. So if you want to move the whole graph up 1 unit, that means your graph will look something like this. Sorry, not balanced. Okay, so assume that the point here is a 1, move up. So this will be 1 plus X squared. So if you you want to put it in to the graph that you want to sketch, so you should have a curve like this. It is half a U shape. I will just sketch it like this. Okay, so for the blue color graph, it will be y equals to 1 plus X squared. All right, so here we already tried to fulfill all the things that they want. The first one is sketch a pair of graphs. I have 2 graphs already for the particular equation that I mentioned here between the interval from 0 until pi over 2. Okay, so how can I prove that there's only one root? So when you're talking about root in the graph, so the root is actually the intersection point for both of the graph. So you can see that how many intersection points between 0 until pi over 2? There's only one intersection point, right? So very obvious that you can see that there's only one root within the interval. So this is a complete graph that you should show them. All right, and then usually I will just make a simple conclusion on this. There's only one root in the interval from 0 until pi over 2. Okay, so this is not hard actually, but you need to make sure that you know how to draw all the basic graph. All right, so usually the graph will not be very hard. Usually they will ask you maybe something like a trigo graph or maybe some quadratic or maybe long exponential graph. Okay, so this is what you have for example 1. All right, so if you understand already, then you can try example 2 first before you proceed to the end of this video. So I will continue discuss example 2, but if you're interested, you can pause the video here, draw the graph yourself and have a look and check the answer. Okay, so let's start with example 2 now. Okay, so again, example 2, you'll see the keyword they want to sketch 2 graphs here. The first one is y equals to cosecant x. Then after that, y equals to x and pi minus x from 0 until pi. And they want you to show that the equation has 2 real roots from in this interval. Okay, so the 2 graphs that they ask you to sketch is y equals to cosecant x, and another one is y equals to pi minus x bracket pi minus x. Okay, so first of all, what I want to do is I will want to sketch cosecant x first. Okay, so again, I will draw out all the requirement that they want. So I will build out the axis, and I'm having 0 until pi. Okay, so usually for me, I will just try to draw a dotted line to remind myself that the interval that I want is only from 0 until pi. Okay, so again, refer to the graph. Okay, in chapter 3, y equals to cosecant square. You can sketch it from sine. Okay, because cosecant x is 1 over sine, right? So I think in chapter 3 video, I teach you how to sketch cosecant x from the graph from the graph of sine x. All right, so for me, I'll straight away draw it in this video. Okay, so y equals to cosecant x, the graph will look something like this. Okay, it is not nice though, but I will just try to draw it as nice as possible. Okay, you have a minimum point, something like a minimum point. Okay, so for this part, the pi is actually the asymptote for cosecant x. So your graph will not touch the pi, the line of the pi. That's the thing. Okay, do you need to find the minimum point? Actually, no need. But if you are interested, you should know that this value is actually a 1. Okay? Alright, so maybe I just label it out. It is y equals to cosecant x. Alright, the second graph that I want to draw now is y equals to x bracket pi minus x. Okay, so to sketch this graph, first of all, you will see that it is actually something like this, x minus 0, and then pi minus x. And if you try to expand it, you have pi x minus x squared. So from here, you know that this is actually a quadratic curve. Okay, and after that, if you look at the sign in front of the x squared, this is negative. So this negative also tells you that it's a quadratic curve with U shape, with N shape. Okay, so all these are small details that you learned before, so you have to know how to apply it now, okay, to help you and sketch the graph. All right, then next one. Okay, to continue with it, I will want to check and see what is the value for the x-intercept. So to check the x-intercept, you let x equals to 0. Oh, sorry, you let y equals to 0. And what you get for the value of the x, so x equals to 0 and also x equals to pi, which means your graph will pass through here, x equals to 0 and also x equals to pi. And also you know that the maximum point, because it is a quadratic curve, right? So both here are the the root. Okay, so you should know that the maximum point will be between this x-intercept or between the roots here, which is pi over 2. If you want to double check, you can check what is the value of y. So with the value for y, you can substitute in the pi over 2 if you want. If you're interested, you can try to substitute it in. Eventually, you'll see that you have pi squared over 2 minus pi squared over 4. Okay, and if you try to simplify, it will be pi squared over 4. So you can use calculator to press for the value of pi squared over 4. You know that it is actually more than 1. So maybe I can assume that this is pi squared over 4, which is more than 1. So it should be an N shape that pass through the 0 and pi value. So your graph should look something like this. Okay, so the green colored graph will be y equals to x and then pi minus x. All right. Okay, so once you settle with the graph already, these are the steps. These are the process that we use okay, to draw the graph. All these steps here, actually, you don't need to show it up in the exam. All right, so this is for explanation purpose. All right. Okay, so after you are done with the graph already, then again, usually I will try to figure out, or maybe try to write out the intersection points. So from here, you can see very clearly that we have 2 intersection points. Okay, so this is root number 1, this is root number 2. Right, so I will make a simple conclusion here. Then you can say that the equation so I just basically try to copy the question. Okay, has 2 real roots in this particular interval. All right, so usually for this kind of question, it will be a small part of the whole question. All right, so for this small part here, usually they will allocate around 2 to 3 marks for this particular question. Okay, so the technique of drawing graph is very important. you need to have all the basic relation on how to sketch a basic graph. Okay, all right. So these are the two examples that we are going to discuss in this video. Then in the next video, we are going to discuss another method to locate the root, which is the sign change method. Right, so I will see you in the next video.